right? So when stress A over stress ultimate tensile minus by stress B over stress ultimate compression is less than 1, okay, the structure, when this is the case, okay, structure will not yield, okay? Or some books, they say will not fail, okay, because it's brittle. Brittle has very poor ductility. Yes, okay. Then if it is stress A over stress ultimate tensile minus by stress B, stress ultimate compression is greater than 1, okay, then the structure will fail or will yield, or some textbook to say will fail. Okay. So stress A and stress B are calculated, right? So stress A and stress B, the principal stresses, okay, are calculated based on.
Professor,
Yes.
the structure fails in both cases?
One will not fail, one will fail.
But it says fail for both of them.
Structure will not yield, will not fail. The bottom one structure will yield, will fail.
Okay, so yielding means failing?
So for brittle material, yes. Ductile material, no. Because if brittle material, what will happen is the yield strength and the ultimate strength are very what? Close. Whereas for ductile material, the yield and the ultimate are very far away, so you'll not fail. Does that make sense?
Yeah, thank you.
Okay. So from here, stress A and stress B, I'll calculate based on structure analysis. Okay. Well, stress ultimate tensile and stress ultimate compression are material mechanical properties, and you can get from handbook, okay, material handbook. Okay, so all these ultimate strength, they are all the tests are carried out in uniaxial direction. Okay, so there's only one direction. Okay, so I will demonstrate briefly or briefly how does this actually work. Okay, through very simple example. So I'm going to change the view again. Right, so I'm going to again copy this, if I may. Okay. So we're going to look at condition number. So condition number 1, let's say we pick up condition number 1. Okay, so let's say we pick a point down here. Okay, we pick a point down here. We call this condition number 1. Okay, that's condition number 1, and we are going to make a assumption that not make assumption, but we are given that the ultimate tensile strength is equal to 4, for example. Okay, and then it's unitless for now. Okay, just for argument's sake, 40 or 400 megapascal. Okay, stress ultimate compression is equal to 600. Okay, minus 600 megapascal. Okay, so condition number 1 is where we have stress A is equal to 100 megapascal, and stress point B, or sorry, stress B, the other maximum stress or the other principal stress is at minus 100 megapascal. Okay, so you substitute into the formula, right? The formula that we're going to substitute is stress A. I'll write it down. So stress A over ultimate tensile minus by stress B, stress ultimate compression. Okay, so this will be equal to 100 divided by 400 minus by minus 100 divided by minus 600, right? So this will be equal to 0.25 minus by 1 divided by 6, or I just put 1 over 6. So this will be equal to 0.25 minus 1 over 6 is equal to 1 over 12, right? So in this case, this value is less than what? It's less than 1. So therefore, structure will not yield. Okay. Then we pick another condition. So we pick condition number 2. So did I get this right? Minus. Yep. Condition number 2. Okay. So condition number 2, where I'm going to pick it somewhere around here. Okay. So this is condition number 2. So you will have stress A is equal to 400. Yeah, 400 megapascal. And you have stress B equal to minus 24, also minus 400. Okay, so this will be equal to stress A over stress ultimate tensile minus by stress B over stress ultimate compression, right? So this will be equal to 400 divided by 400 minus by stress B, which is minus 400, divided by 600. Okay, so divide by ultimate compression 600. Now I like to apologize something. I think I did something wrong. The compression over here, you don't put a minus sign. Okay, I do apologize. You just put 600 over here. Okay, so if that's the case, over here will be a plus. Okay, so 0.25 plus by 1 over 6 is equal to 5 over 12. My apologies. Okay, then when you do this, right, so this will be equal to 1 plus by 2/3. So this is 1 plus 2 over 3 is equal to 5 over 3, which is greater than 1. So therefore, structure will yield. Okay. So this is how it works. So a key thing to remember, right, which I made a mistake earlier, if this is 600 minus 600 over here, you leave it as positive down here. Okay. Right. So I'm going to quickly do one example. Okay. Anyone, any questions so far? Anyone? I don't hear anything. Okay. So we look at so this is a demonstration of how it works. Yeah, one, condition number 2. So I'm going to do example number 1. There is just one example. So given that we are given that the ultimate tensile is equal to 10 times 10 power 3 psi, and the stress ultimate compression is equal to minus 30 times 10 to the power 3 psi. Okay. Then we are given a load, or we are given a 3D element, right? So I'm going to sketch a 3D element. So this is X, Y, and over here is Z. Okay. So this is our 3D element. So on our 3D element, we have the following loading condition. Okay. So this is equal to 2000 psi. Then we are given compression over here, so 15,000 psi. And then we have a shear. Shear is going at 9,000 psi. Okay. And then nothing else. Okay. So the question asked is, were the material, okay, yield under the loading condition okay, and it's going to be based on the simplified Mohs criteria. So we know that this is going to be brittle material now. Okay. You cannot use Mohs criteria for ductile material. Okay. So the first thing we're going to do is we know, if we look at the formula, is stress A over stress ultimate tensile minus by stress B over stress ultimate compression. Okay, and this whole thing is equal to 1. Okay, so we want to find if, okay, so we have to find stress A and stress B. Okay,